hello everyone. Let's start with, we're going to go back to the beginning. In the beginning was math. Yes. Okay. I want to start with one of the simplest graphs we've ever started graphing in this semester. This is the graph of y equals 1 over x. There's a lot of things going on here. I just felt like putting y. I didn't have to. I just felt like it. Let's start with the horizontal asymptote. The horizontal asymptote is y equals 0. That means there is a dotted line that goes across that will never touch. So if I were to graph y equals 0, there's a line. I don't know how to make it dotted. I think there's a way. Not that important. But that's a horizontal line that this graph will never touch. Well, that's interesting. What's this? Oh, cool. All right, there alone. All right, so it'll never touch that line forever. We're going to focus on the horizontal asymptote. Okay. Well, if it's a type 1 function, it has a horizontal asymptote of y equals 0. That's very important. Okay. And if you hadn't been in this class, you don't know what I'm talking about. So let's focus on figuring out which one of these functions are type 1 graphs. That means the exponents are larger in the denominator than the numerator. So this number 1, this is type 1. We'll circle those in blue. So that's a type 1. Let's go through. Nope. Type 1. So my type 1s all have a horizontal asymptote of what? Yes. Y equals 0. So let's go through. Nope. 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 Type 1. That will have a horizontal asymptote of y equals 0. Okay? Excuse me. I'm not making anybody contagious at home. All right, so that's my type 1 functions. All right, that's my first thought. Horizontal asymptotes are easy. You just have to remember what type of function it is. Okay, well, I want to start with that one and kind of work out. Type 2 functions are the functions that have the same exponent, and we're talking about the leading term. If I look at the leading term, if it has the same exponent, it has a horizontal asymptote of whatever the number is in front. I'm going to call it A over B. So number 2 will be type 2. So number 2, I'm going to circle those in red. That has a horizontal asymptote of 1. Y'all remember that? If not, you don't know what I'm talking about. Let's see. This one has a horizontal asymptote of 1 over negative 4. We're looking at the numbers in front of the leading coefficient. Okay, let's keep looking. All right, number 6, leading coefficient, that's y equals 1 over negative 4. Same as that. This one here, number 7, type 2, that has a horizontal asymptote of 1 over negative 2, or negative a half. Let's keep going. Here we go. That has a horizontal asymptote of 3. And this one has a horizontal asymptote of negative 1/4. What's up, this negative 1/4? All right. This one over here has a horizontal asymptote of a half, 1 over 2. And this one has a horizontal asymptote of 2. All right. And I think that's it. All right. Let's go. What's the next type function? We have type 3 function, which I wanted to call the other ones 3 and 3b because they're so related. So basically for type 3, you have the exponent is larger in the numerator. And for type 3 functions, it does not have a horizontal asymptote. Okay? If it's only 1 away, if the numerator leading exponent is larger, it's going to have a slant asymptote. This worksheet does not give you the solutions for slant asymptotes, but we'll work out one of those so you can see it. But I just want to make sure we understand that. So type 3 function, this one, there's only one difference in the exponent. This one will have a slant asymptote, and we could calculate it. Let's keep going. This next one, number 8, will have a slant asymptote. I think this was on one of the tests. Most of these were on the test. I just use these same ones, examples. This one, slant asymptote, no horizontal asymptote. And that's it. And let's go down here and cheat. Let's not cheat yet, but that's it. Focus on the horizontal asymptotes first, type 1, 2, or 3 function. Again, this is a review just to kind of help you to focus on these types of functions. And after that, we need to find points of discontinuity. I like to do that next. or the vertical asymptote, either one. Points of discontinuity is just whenever you take your denominator and you factor it completely. So if I factor that denominator, this one number, let's look at number 2. If I factor this denominator, there's nothing to factor, it's just x minus 4. But if I factor it, my solution will be 4, because 4 will make that denominator 0. Okay? And the other ones, if I factor denominator, that's going to be where you get your vertical asymptote from. It's what makes the denominator 0. Okay? Let's do one since we're talking about it. Let's do this one over here. The first one over here, to find the vertical asymptote. If I take this and factor it, I'm going to factor out a 3. Let's stay with the same color. So if I factor out a 3, I'm going to be left with x squared plus x minus 6. You can factor that to something. X and x, what times what is negative 6, add to give you 1. That's going to be plus 3 and minus 2. So now notice this one, in my denominator, whenever you factor this, if I plug in a negative 3 or a 2, it's going to make that denominator 0. So this one will have vertical asymptotes of x equals negative 3 and x equals 2. Okay? All right. Hope this refreshes your memory. Let's do another one. Let's look at number 5 down here. If I factor this, if I factor out an x, I'm left with x minus 3. This one, I'm glad I did this one. Notice I have an x just by itself. This will give me a vertical asymptote of 0 and a vertical asymptote of 3. Don't forget that 0. We forget that 0 a lot. Okay, that's vertical asymptotes. And the other one's the same thing. You just have to factor it. Okay, you got to factor it. All right. What's next? Points of discontinuity. Those are what I just talked about. Points of discontinuity is kind of like vertical asymptotes, but a little different. Let's do one where it's a little different. Just a little. Let's do number 8 here. All right, number 8. If we notice and remember, let's factor the denominator. I'm gonna factor out a 3. I'm left with x squared minus 2x minus 3. Okay. In my numerator, I'm gonna factor out an x. I'm left with x squared minus 9. Okay, well, you can factor that even further. That's going to factor the x times x plus 3, x minus 3. Over. In the bottom, I have, let's see, that factors to factors of what times what is negative 3 to add to give you negative 2. And if I'm going too fast, pause. That's the nice thing about making a video. I can go as fast as I want. You just have to pause. I know in class a lot of times it's hard to slow down, only because we have so much information to cover. That's why sometimes it looks like I'm going fast. Well, I am going fast. All right, so notice on this one, let's cross out x minus 3. So my POD for this one, to kind of go through and review, are going to be every place that the denominator would have been 0. So that would have been 3 and negative 1. Okay, if y'all remember this from class. All right, my next were my holes. This one's nice because it has a hole. And again, we're just reviewing, not going to graph all these. My holes are where whichever one that cancel, where it makes it 0. So my hole in this problem is just going to be 3. Okay, there will be a hole in your graph. All right, next, what about my, what type of graph is this? This is a type 3 function because it's 1 away. So this one will have a slant asymptote. We'll have a slant asymptote. What does that look like? All right, let's keep going. All right, so now what I want to do here, I know my vertical asymptote is going to be, I'm looking at the one that's simplified. So it's going to be x equals negative 1. Okay, this has a slant asymptote. This one's fun. And my slant asymptote is I have to divide my denominator into my numerator. This one's a little interesting. Remember, when you find a slant asymptote, you need to do long division. Okay? So the way I do this, I'm going to say, 3x squared minus 6x minus 9 into, well, this is interesting, x cubed minus, well, notice there's no x squared term, so I'm going to put plus 0x squared, and then I'm going to put minus 9x. All right, and then I'm going to say this one was a challenge. I remember you're saying 3 times what is 1 x cubed? Well, that's 1/3 x. Now, if I multiply this back out, 1/3 x times this is x cubed. Multiply this out, that's negative 2x squared. Multiply that out, which is negative 3x. But honestly, I don't even care about this, because if I take the next step, change my signs, I'm going to have a remainder. I don't care about the remainder. This 1/3 x is my slant asymptote. So my slant asymptote is y equals 1/3x. And that's it so far. I think this is all you need to graph it. You could possibly find you some points, but let's go ahead and look at the graph. Watch this. I'm going to cheat. I'm going to go down here to number 8 because I have the answer. There is my graph. Notice my horizontal asymptote, it's none. Well, that's because this one didn't deal with slant asymptote. So if I were to graph the function y equals 1/3, that's going to be your slant asymptote. And it also there's your vertical asymptote of x equals -1. And that's it so far. Hopefully that helps. I think this is a good quick review. I just wanted to get your mind focused on graphing rational functions, and then we'll go over polynomials next. So this will be video part 1.